Hello, welcome to a new video. Today we're going to do to sum 2 input array is sorted. This is a medium problem in LeetCode number 167, and I'm going to solve this using my problem solving process. Given a one indexed array of integers, numbers that is already sorted in non-descending order, find two numbers that add up to a target number. Let those numbers be whatever, whatever, where where the index is 1 through the number length. Okay. So we're supposed to return them in one, yeah, one in one index, I guess. Yeah, yeah, return the indices. Okay, the test is guaranteed that there's such that there's exactly one solution. Your solution must only contain extra space. Okay, so so what I've got from that is that our input is basically going to be array of nums sorted. That's going to be the important part. Our output's going to be indexes by 1 added by 1 that add up to sum, and then we're also given sum as well. Sum, and then yeah, sum. Okay, so or target value. Okay, so now that I've got input and output, some questions I would like to ask is like I wouldn't ask about the constraints of complexity, but I would ask like are there, even though this is I don't think this really matters, but just some like notes, right? Are there negative numbers, and then um do I return the index in any order? Well, I mean in any way, 0th, 1st, 1th, or whatever. So yeah, that is basically some questions that I would ask, and then here they would say, yep, there is it's added by 1, so it's 1th, and then there are negative numbers because of right here, and then I would ask, um do I have to put in any error checking, like if user puts in like invalid length maybe of 1, and they would say no, so which is right here, that's good, or 0, stuff like that, so that's good. Now that we got that information, I'm pretty sure I do understand the problem, so let's go over some examples to like kind of showcase that, hopefully. Example 1, let's say our input is 1 2 3 4 5, and then there must be exactly one solution. Okay, so this has to be okay um okay, so there's exactly one solution for this one. Okay, so let's say, oh yeah, that's it, put notes there, so exactly one solution. Okay, for this example we have 0 1 3, so let's just say it's 4, right? Our target's 4, so we would output the indexes 2 and 3, because again we basically get the actual indexes but add by 1 that add up to the sum, right? So index 2 is technically right here, which is value 1. Index 3 is right here with the value of 3, so 1 plus 3 equals 4, so that's why we output 2 and 3, right? Let's go through another example. Example 2, just one more. Let's say we have 4 6 4 6, and then 8 and 10, right? Let's say we want 14. Okay, pretty sure 14 should be a unique answer for that. in this list. It should be 10, 11, 12, 13, 14. 7, 8, 9, 10, 11, 12, 13, 14. Oh, no, it's not. It's only like it's a 7. There you go. Now it's unique. Now it's unique. Okay, so get the output. Well, we obviously know that 4 plus 10 is 14. So we gotta get that, right? So that's the unique answer. So 4 is at index 0, but plus 1, so that's 1. 10 is at index 3, but plus 1, so that's 4. And yeah, that's the output. Right? I'm pretty sure that's we do understand the problem. So let's just go ahead and move on. All right, let's go and move on and get some approaches that we can do. So for me, we could obviously just do like O of n time, I guess, or just iterate through list. Then each iteration, yeah, each iteration, what do? We iterate through list with hash map. With each iteration, we can calc cur minus target, put into hash, put diff into hash, and then what you call it, check. We would like check every iteration if it's a diff hash. If not, then it's whatever. And then yeah, get the difference from the hash, right? But we can't really do that because our solution says that it has to be using only constant space. So we can't really do that. Well, what we can do is we can do O of n because we're not using constant space, right? Basically, nest loop, find diff to find sum, right? We can do that, but that'll be too much time, I guess. So what we can do, thankfully that's binary. It's binary search. I mean, thankfully that it's sorted. We can do binary search possibly. So I think we can do O log n. What I'm thinking about is that right. I think we could do the same thing where we go through each iteration, right? Go through each number in the list, and do binary search to find its target, I guess. So we can still like iterate through list. Instead of hash map, instead of hash, use constant space. And what we can do is that we can say like, okay, so get diff of current, then use binary search to find diff. Get diff of target, cur minus target. Binary search to find diff, right? And then if not found, then it's whatever, right? I think that's how it's supposed to go. Like that kind of makes sense, right? We'll see. But the only thing that's gonna be interesting is like determining if it's not found, right? So, oh wait, no, it's easy. While left, and right. Okay. So now that we found an approach, I feel like we could definitely do this. So let's go and start. I'm gonna make a plan for this one. So let me see. So we can get user input, of course. User inputs, and then we gotta do binary search. I know we gotta do a for loop. So for loop iteration, for loop. So for loop, so I can say iterate through list. So I can say for nums and num for num and nums. I think I can do this. I think that wouldn't be bad. Yeah, for num and nums, we can say num and nums do binary search. Oh no, we need to get diff first. So we can say like diff is equal to target is equal to what would it be? I'm I'm pretty sure it'd be target minus current. Would that be it? Let me see here. So I know it'll be let me think. It would be cur plus cur minus cur minus I can't think right now. I just woke up. Cur minus target. There you go. There you go. Okay, cool. We got it. And so yeah, that would work with negative numbers too. My brain's not working right now. I just woke up like 30 minutes ago. So get diff, and then we do binary search. So binary search to find diff. To find diff. Right. So we can do we gotta initialize left and right. So left is equal to 0, and right is equal to length of nums minus 1. Right. Then do so while left is less than right. That's an equal to right actually. You can do basically binary search. So so if oh yeah, we gotta calculate middle. Oops, I forgot. So middle is equal to 0 as well. Right, so while that's less than right, so we gotta calculate middle, right? So middle is going to be left that's right divided by 2, and then we gotta check if nums at mid is equal to target is equal to diff, then we gotta return oh wait, actually I think I'm just gonna make this like an in range, because for I in range, I think the nums. So we can get the index of it pretty fast. So return so if we do find the difference, then we can just return we can return I and then m. But else if that's not the case, so else if what you call it, nums m is less than diff. Yeah, if it's less than no, if I'm gonna say more than, because I'm used to it, is more than diff, then we gotta search through we gotta search to the left. So right got to get move to the left. Right is equal to middle minus 1, and then that's not the case, then it has to be that that nums is less than, so we gotta move left to the right. Right. So we do this, and then I think we should find diff or not. I believe that if it's not in it, then we'll be out of range, and then this while loop would break basically. And then I feel like just go through this, keep on going. I feel like this would work. Yeah, there should be only one solution, right? So I feel like this would work. So yeah. I think this would be fine. Oh, and log n, not bad. But let's go ahead and basically just review this. I think this will work. Like, it makes sense to me. Let's say we start at 0, right? We go through it, binary search with this. Let's see. So difference would be 4, right? Because 0 minus 4. Oh, wait, 0 minus 4. Yeah, would that be correct? 0 minus 4. That'd be 4. Wait, that'd be negative 4. Would it just be target minus current? Yeah, so 4 minus 0. That's 4. Oh, in this case, oh wait, wait, hold up. I'm trying to basically fix this. So this example was 14, I'm pretty sure, yeah. Yeah, so let's go over this example. So we go at 0, so 4 minus 0, that's 4. Let's try 4, 4. Right search starts here. Look to the right, it's not there. So, and it breaks. So we go ahead to the next one. We're at 1. 4 minus 1, that's 3. We look for 3. It starts here. And then we have to find it. Find 3. It's right here, so it would turn 2 or 3. About this case, at 4, we start here in the middle somewhere. We look for 10. We go to the right, find it. Right, I think that's how it's supposed to go. But let's go actually do example with negative numbers. So 3. I think a good example was -1 and 0. Our target is going to be -1. And so let's go output. So we know that it's going to be 1 and 2 because index plus 1, right? Let's do that. So -1 minus -1. Isn't that like -1 plus 1 now? I'm pretty sure. I'm really stupid right now. Let's just try it. So -1 minus -1. Okay, cool. All right, cool. So, okay, cool. So yeah, this should work with negative numbers as well. All right, so let's, I feel like this will work. So let's go ahead and plan it. I mean, let's go ahead and implement it. So, I'm gonna pretend like we don't have a driver, so we gotta create one. So main, pass it. Then I'm gonna run main. I'm gonna make a function called what's the name of this problem? So define this function, get to sum. Okay, it's gonna take in an argument of nums and target. Tar for short. No, let's just do the target. Pass it for now, so it looks good. Let's get user input and target. So user array is equal to empty array. I'm gonna get the input, split it. And then I'm gonna say like for nums in there, turn this into integers. And then let's go get user target. So user target is equal to integer input, basically. And then let's go call get to sum with the arguments of user array, user target. And let's go ahead and print this out because I know I'm going to output the indexes, indices, same thing, right? So let's go ahead and do that. Let's go ahead and actually code this part. I'm gonna copy my plan line by line basically. So we got user input and now we gotta iterate through the list. So for I in range, starting from the length of nums, up to the length of nums, right? Let's go ahead and get a difference. So diff is equal to target minus nums at I. Okay. Then we gotta do while loop to do the binary search. So while, yeah, we gotta do initialize left and right. So left, right, and middle equal to 0, length of nums -1, and then 0 itself just to initialize it or assign it a value, right? So then let's go ahead and do a while loop. So while left is less than equal to right, we're going to keep finding, we're going to do binary search to keep finding the target, the diff. So if, we got to set up middle, right? So we got to find middle by doing left plus right divided by 2, then we find the middle. We got to say, okay, once we find the middle, we got to say if the middle index value is equal to diff, then we got to return the indices of I and M. We find the diff. And then else if nums at M, the middle value is more than diff, then we gotta look to the right. And we gotta look to the left. So we gotta move right to the left. And then else the opposite. So +1, and then it should work. There should be exactly one value. One solution. So we don't have to do like a return -1 or something like that. I'm pretty sure. I think this would work. Let's just try this out with our 0. -1 and 0 and target 0. Oh, That shouldn't be the case. Um, yeah, that shouldn't be the case. -1. Yeah, that shouldn't be the case, right? Because target is 0. Oh no, that way, no, that's correct. That's correct. The example was -1 and 0, and then the target was -1. Okay, there you go. Okay, so that works. Let's do some other examples. I think this one's pretty good. Let's do 0, 1, 3, and then 4. Okay, so that works. Oh yeah, I need to do +1 actually. Hold up. Where's my thing? Turn I +1 and then m +1. So that example works. What about this example? F4, 6, 7, and 10, but we want 14. 1 and 4, that's correct. Okay, so it does work. Let's go ahead and copy and paste this into LeetCode to see if it actually does work with all the test cases. Okay, so I'm gonna replace this with nums, and then target is the same thing. Okay, cool. So this should work. So run it. Oh, indentation error, really? Wait, how? Oh, I'm stupid because of this for loop. Okay, cool. Should work now. Okay, accepted. Wrong answer for this one. So okay, so target's 4. Target's 8. And then there's gonna be some cases where our numbers are equal to each other. I mean our differences are equal to I. So how would I do what would I do? So I think I can make like an if statement here somewhere. It's like if nums is equal to diff and nums m. Wait. Wait, how would I do that? Because it is equal, right? So if nums is equal to diff. Oh no, if I okay. So I gotta say what you call it? So I guess I can say oh wait, yeah. If nums and nums at I doesn't equal to diff. I think that should work with that case. Let me just copy paste this test code. I can just use this test case and run it with this code. So and nums at I does not equal to diff. Okay, cool. But I think this should work now with this test case. Wrong answer still? Um oh wait, I'm so stupid. Because the diff is wait, hold up. So it should be 4 and 5. 0, 1, 2, 3, and 5. So I is 5. I is 4. Oh, and nums oh, I'm stupid. And nums m and m does not equal to I. There you go. That should work now. Yeah. I was looking at it in a different way. But yeah, my brain cleared up. So it should work now hopefully. Cool. Oh damn, it actually sucks. My solution sucks. But but it is using only constant space, so that's fine. I'll probably look at a solution later. I can probably look at it right now. But oh, this is what I did. This is exactly what I did. Is this what I exactly did? I don't think so, but it's similar. I think I did it in a weird way. I don't know how I did it, but I'll probably look at it later. So yeah. All right. Anyways, so yeah, that was my solution. Yeah, I hope you guys liked it. To evaluate, to evaluate, this is kind of like O n log n, because you're going through every number, or we could go through every number, worst case, and then do binary search to find its difference to add up to target, right? Difference and its sum to add up to target. Yeah, there you go. So yeah, that's pretty much it. Yeah.